Hi everyone, in today's lesson we're going to talk more about applications of exponential and log equations. So previously we've spoke about the annual compounding formula, which is here. We use it when we're talking about money growing exponentially, or in this case, depreciation of a car. So we already did part A in a previous video, and I'd like to do parts B and C now. So let's reread example number one. It says, Miss Amvini bought a 2015 Honda CR-V for $30,000. It is known that the car depreciates at a rate of 20%. The value of the car at any time can be determined by this formula, where V is the value of the car after T years, C is the original cost, and R is the rate. So I'd like to solve part B. How old would the car be to the nearest tenth of a year if the car has a value of 15,000? So in other words, how long would it take for the car to be worth this amount of money, right? In a couple of years' time, the car is not going to be worth that $30,000. So let's start with writing the formula. I'm going to write it a little bit above it here so I have some space. So I have A equals P 1 minus R to the T power. Now I'm going to use the minus because we're depreciating. Remember that P is my starting value, A is my ending value, R is my rate, and T is my time. So in this case, what I want to solve for is time. So we're going to leave T as T and we're going to solve for it. So we start the car with $30,000. So that's going to go in for your P. So 30,000 is what I start with. I want to know how long it will take for it to end or reach $15,000 when the rate of depreciation is up here 20%. And remember, we have to take that 20%, move the decimal 2 places to the left, and input it as 0.20. And we're going to solve for t. So the first thing that we need to do is isolate the base. And the base in this case is the stuff here in the parentheses. So I actually can subtract this, 1 minus 20 or 0.20. So think of it as 1 minus or $1 minus 20 cents. How many cents do I have left over? And you should be telling me 80 cents. So 1 minus 20 or 0.20 is 0.80. So now our job is going to be to isolate this 0.80 to the t. And the way that we're going to do that is we're going to divide out this 30,000 on both sides. Because the 30,000 is attached to that 0.80 by multiplication, the opposite operation is division. So the right side, we're left with 0.80 to the t. And the left side, we'll just do the division, 15,000 divided by 30,000. And if you put that into the calculator, you'll get 0.5 or 50 or 1/2, excuse me. So now we're at this stage. We're trying to solve for an exponent. So the way that we solve for exponents is we log both sides. So we're going to log the 0.5 and we're going to log the 0.80 to the t. And then remember, log properties say we could take the exponent, drop it like it's hot. So we have log of 5, I'll write it over here. So log of 0.5 equals t times log of 0.80. And then to get the final answer, to get t by itself, we're going to divide by log of 0.80 because the t is connected to that log by multiplication. So the opposite of multiplication is division. So to get our time, we're going to simply put this into the calculator. Log of 0.5 divided by log of 0.80. So I'd like you to take a minute, pause the video, type that into the calculator just the way you see it, and then hit resume when you're ready for the answer. Okay, so you should be getting approximately 3.106. So if we answer the question, to the nearest tenth of a year, how long will it take? And that answer will just be 3.1 years. So conceptually, let's think about what we just found. We said that in about 3 years, this car that's worth $30,000 is now only going to be worth a value of $15,000. So this is a good example of why they say cars are a really bad investment because they lose value over time. And specifically this amount of time in 3 years, I've lost half of its value. So that's a significant difference. Okay. So what I'd actually like you guys to do right now is model the same steps that we did before, and I'd actually like you to try part C. I want you to find out how old the car is to the nearest tenth of a year if the car will be worth 5,000. Okay, so same concept as we did in part B. So I want you to follow along by plugging all the values in and solving 4 times. So isolating the base, drop it like a tot, and then divide. All right. So I'd actually like you to try this one on your own, and then we will go over it in class tomorrow. All right, let's move on to the next example. Okay, so same example as before. Now we're using the compounded formula for compounds other than annually. We did part A already, so we're talking about Nick investing $1,000 at Chase offering a 2% interest. So now I'd like to solve part B. Part B says, approximately how many years will it take Nick to make $1,500 if his money is compounded quarterly? So now that we have compounded quarterly, we know that quarterly means 4 times per year. So this piece of information will tell us the variable for n is 4. And they want to know how long it will take him to make $1,500. So we want to know how much it will grow to $1,500. That's your A. And how much was he starting with is your P. So that's still not changing. So I'm going to start with plugging in our values. So A equals P, 1 plus R over N to the NT power. So the 1,500 is the end value. We want to know how long will it take for it to grow there. If we start P with 1,000, my interest rate in this case is 2%. So remember, 2% is a decimal, 2 places to the left is 0.02. I'm compounding quarterly, so my N is 4. And I want to solve for T. So this problem, same as we did before, we are just going to isolate the base. So this base is quite obnoxious. Let's put that in the calculator first and solve that and simplify it. So take a second, pause the video, and then hit resume when you're ready for the answer. Okay, so I got 1.005. So we're going to leave the 1,500. We have the 1,000. 1.005 to the 4t power. Much cleaner now. So again, like we did before, we're going to isolate the base. This is the base that we're going to isolate. So we're going to need to divide out that 1,000 from both sides. So the right side's going to stay the same, 1.005 to the 4t power. And go ahead and type this into the calculator just the way you see it, and then hit resume when you're ready for the answer. Okay, I got 1.5. So that 1.5 is not a repeating decimal, so we get to keep it. So now we're in the stage where we've isolated the base and we're going to log both sides. So I'm just going to continue my work over here. So we're going to log the 1.5 and we're going to log the 1.005 to the 4t power. And then we take the exponent, drop it like a tot. So we have log of 1.5 equals 4t times log of 1.005. And again, we have to isolate the t. So first we have to get rid of this log. So we can do that by dividing both sides by log of 1.005. And we're going to set that equal to 4t. So again, take a couple seconds, pause the video, type this into the calculator, and then hit resume when you're ready for the answer. Okay, so I got about 81.2955, and we're going to divide that by 4 to get t by itself. So again, you don't have to write all of the decimals, just keep them in the calculator and then hit divided by 4. So when you're ready, pause the video until you're ready for the answer. Okay, so I got 20.32. Obviously, it goes on forever, but the directions say approximately how many years. So that just means in full years. So approximately 20 years. So again, think about what you just talked about. We're talking about Nick putting money, $1,000, into a Chase bank, offering a 2% interest rate. So we want to know how much it starts with at 1,000 and how long it's going to take him to gain $500. And he's only going to gain that $500 in 20 years. So that's a really poor interest rate. Because it's so small, it took him so long for his money to grow. All right. I'd like you to see if compounding monthly makes any difference. I'd actually like you guys to try part C on your own, and then we will go over it in class tomorrow. So again, give this one a shot, and then we'll move on to the next problem. Compounding continuously is always our PERT formula. So again, we did part A already. I'd like to do part B. I'm going to set it up, and then I'm actually going to let you guys solve it yourself just for purposes of time. And then we'll start by going over these in class tomorrow. So we're talking about Susie investing $2,000 in a bank account, and it's compounded continuously with an interest rate of 1.5%. A is the amount accrued. That just means the ending amount. P is the principal, and R is the rate. So again, we did part A already. I'd like to do part B. So how long will it take for Susie's money to double? So same concept like we've been working with. So we're starting with $2,000 this time. So if we're doubling that, the A value should be 4. The initial value should be 2,000. E is part of my formula, right? It's A equals PE to the RT. The rate in this problem was 1.5%. Move the decimal 2 places to the left. We get 0.015, and then to the T power. So again, we're going to isolate the base. So the base here is this E, and we want to isolate it. So I'm going to divide by the 2,000. And 4,000 divided by 2,000 is nothing other than 2. So we've got 2 equals e to the 0.015t. And we're going to log both sides. So we're going to log the 2. And we're going to log the e to the 0.015t. And then we're going to take the exponent, drop it like a tot. So we have log of 2 equals 0.015t times log of e. So exactly the same process. Divide both sides by log of e. Put that into the calculator just the way you see it, the log of 2 divided by log of e. And you should get a decimal of 0.6931 ... equals 0.015t. And then we just divide by the 0.015. Remember, using all of the decimals in the calculator, don't round it until the very end. And you should be getting 46.209, so approximately 46 years. So that is a long time to wait for your money to double. Well, it makes sense when you have such a small interest rate. So notice all of these problems, they're exactly the same, right? Every single one, we're isolating the base, logging both sides, dropping the exponent, right? Now, I know we had talked about ln'ing both sides with an e. You absolutely can do that, but just for consistency, I decided to do this problem with logs. All right, so I'd actually like you guys to try part C on your own, and then we will go over it in class tomorrow. So all of the part C's actually we'll go over in class tomorrow. If you have calculator questions or anything that you're unsure of, please jot down the questions now, and we'll touch base again tomorrow. All right, have a good night.